Those of you who started on the Khan Academy last night, how was it? It was rough? Not that bad? Okay, once you got some practice, the longer you wait to get that practice, the harder it's going to be. What I'll say. Okay, if you wait to get that going until today, it's going to just be a little bit harder than if you did it yesterday. So, just want to put that out there. Okay, so I want to pick up where we left off. We got through a couple of these, I think, yesterday. Is that true for your class? We got through A and B, and that's it. Right, but we kind of sped through them, I think. So I just want to refresh your memory. I would make sure these are well written in your notes. These are very, very common multiple choice questions. There's not a lot of work to do. The question is really just what does the following find? And so you want to make sure you understand what the question is asking. It's not asking you to solve this. It's not asking you to multiply this whole thing out and simplify it and find an answer. Just asking what it finds. So yesterday we talked about the definition of the derivative, which was f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. Remember, we used our slope of a secant line, then we took that second dot and we moved it as close as possible to the first dot. That's where the limit as h goes to 0 comes from. H was that distance away between the two dots, right? And then we came up with this equation. The other version of this equation was f prime of a specific value, so like f prime of 2 or f prime of 3 or f prime of 5. And we said that the limit as x approaches a for f of x minus f of a over x minus a is going to give us our f prime of a. Okay, there was no h in that version of the equation. So really, same idea. I wanted the second dot to move closer to the first one. So I wanted the limit as x approached a. Okay, so this a was in the form of that first equation. We had some function of x plus h minus f of x, right? So minus x to the fourth all over h with the limit as h goes to 0. So what we said yesterday was what this finds is f prime of x if f of x is equal to x to the fourth. That's what we're finding in that situation. Okay. The second one, B, was very, very, very similar to A, except we were not finding f prime of x, which is what this one found. We were finding f prime of 2 because it's 2 plus h minus 2 to the fourth. Okay, so we were finding f prime of 2, but still, if f of x was equal to x to the fourth, right? So this first equation can also be used to find a specific value, just like we showed over here. Like f prime of 2 is going to still equal the limit as h goes to 0. I'm just using 2 as an example because that's on there. Of f of 2 plus h minus f of 2 all over h. And that works for any specific value. Okay? Questions on A or B? We did not start C. Is that correct? Okay. Write down C. So it's the limit as h goes to 0 of e to the 3 plus h minus e cubed all over h. I want you to tell me what we're finding. So write that down in your notebook. Consult with the people around you. Go. What do you think we're finding here?
This is the normal variable e dot d, like log.
This is e like log. Anytime you see e in calculus, it's going to be e like that number 2.7. So yeah, that's not a variable. Okay. Anyone think they know what it is? Anyone have a guess? Yes, sir. Agree or disagree? Okay, thumbs up, thumbs down. Where are we at? Thumbs down. I also disagree, but you're close. Anyone else think they know? Yes. f prime of 3 if f of 3 equals e to the x. I also disagree. Also close. Yes, sir. That's correct. Okay, so you guys are all close, right? You're all around the right thing. Okay. So if I just asked you to find f prime of x, if it was e to the x, if I just asked f prime of x, you would get limit as h goes to 0 of e to the x plus h, right? Because we have our f of x plus h, minus e to the x all over h. That's what would be f prime of x. But we have a 3 here and a 3 here. We have a 3 plus h and a minus e cubed, which means we are not finding it in general for any value, right? That's when we have an x in our answer. We're finding it specifically at 3. We're finding the derivative of this function, e to the x, when x equals 3. Okay, what questions do you have? Okay, yes. Correct. I totally agree with that. This, because you see that plus h and a limit as h goes to 0, you should be trying to think about how is that similar to this? How can I kind of make this out of what I'm given? Exactly right. That's the whole question is that. That's all you're doing. Okay. Now, D and E are slightly different because D and E do not have a what letter in them? An H. Okay, they are still a limit question. Not every limit question is going to be a derivative, but these are. I want you to see if you can figure out what the question is asking for, what it's finding. Okay, with your partner, go through D only, just D. With your partner, go.
Except for F of
We're just doing D. Just D. I'm going to give you about another 20 seconds. Consult with the people around you if you think you got it. You have no partner today, just consult with the guys near you. Same with you. Your partner is gone today, so just ask these guys around you. Okay, give it another 20 seconds. Some of you figured it out or suddenly feel confident in your answer. You've looked at it now like 10 times and you're like, it has to be this. I have to be right. Okay. This is the second form of our definition, right? There's no H in here. So this is this form where I have f prime of A equals the limit not as H goes to 0, but as x approaches A, whatever that number happens to be, of f of x, my regular function, just f of x minus f of A, that function with that number plugged in, over x minus A. Raise your hand. What is this finding? Yes. Bobby. Thumbs up, thumbs down. Some of you don't have thumbs. Thumbs up. Excellent job. It's exactly the same thing as the previous one. These are the two different ways that you could write the definition of the derivative here, right? This one is with an H. This one is without, but they're finding exactly the same thing. Okay? All right, this one. What is this finding? I want you to write it down. I'm only going to give you about 10 seconds. See if you can figure out what this one is finding. Look at it. Yes, sir. Absolutely correct. Okay? Here's what's kind of nice about this form. By the way, you're going to do this one a lot more. You're going to see this one a lot more. So sometimes students get less comfortable with this one. I think this one is easier to identify because your f of x is like right here, and whatever you're finding is right here, in both of those places. Okay? So I think this one's a little easier because you're actually going to see what f of x is in the equation. But you do have to be comfortable with what both are doing. Okay? Are there any questions on these? Again, I didn't ask you to solve these, right? I didn't ask you to actually work this out. So just make sure you're reading the question carefully. I'm just asking, what does this find? Which is a very common AP College Board question. Yes. Okay, so my function, if I was just finding f prime of x, right? We know that the first thing I would have to do would be to find f of x plus h. Okay? If my f of x, if I'm telling you off the bat, f of x equals e to the x, right? To find f of x plus h, we substitute in x plus h wherever there's an x, right? So that gives me e to the x plus h. Just like on yesterday's, we had an x squared, and we substituted in an x plus h for the x. You do that here as well. And now, since we're specifically evaluating it not just for f prime of x, which would be this, e to the x plus h minus e to the x over h, we're evaluating that f prime of 3. We plug in a 3 for those x's. That is a little challenging. Okay, any questions? Okay, we are going to do another example. We did a couple of these yesterday. I want to do another example to make sure we remember. We talked about slope of secant lines, slope of tangent lines, how to write an equation of a line, the three things you need, that we're not using y equals mx plus b, that we are always using point slope. Okay, so using the definition of the derivative, because we are finding the tangent line at any point, it says find the equation for the slope of the tangent line. It does not say find an equation for the line. It says find an equation for the slope of the line. Okay, find an equation for the slope of the line. With your partner, consult. What are you finding and work on finding it together. Go. Why is it all quiet? Have we started doing this at least, I hope? Of course. Some of you, I don't know what you're doing. I have literally no idea what you're doing. Okay, we're not factoring. We're finding the slope at any point of the tangent line. That means we're using the derivative. This is the derivative. We have to find f of x plus h in order to simplify this big equation. Okay? I'm not going to keep going because I need you to make sure that you can actually work out what this is. I promise I'll pick up in a minute, but make sure you can work through that. Go. With your partners, make sure every line is correct. Okay, so now you need to find what f of x plus h is. So plug in x plus h in for x, and then expand it. So here, right, we have 3x squared minus 5x plus 8. X plus h goes in there. X plus h goes in there. So that's where our x's are. Okay. And then we're going to keep expanding. So you're going to actually square it. You're going to actually multiply by that negative 5.
Cancel.
Don't forget to write limit as h goes to 0. Don't forget to write limit as h goes to 0. Don't forget to write limit as h goes to 0. It does mean something. That's true. What'd you get? Oh. No.
Oh, guess what?
Y'all are close. Okay. Okay. Good. 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 Check in with the gents around you. What did you circle?
The slope is 6.
Dang. No, but you're close. No. 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 You had it. You went one step too far. Come with it. I don't know how you've labeled this, but you're very, very, very close. No. Okay, we'll see. All right, let's go through this. You do have to know how to start the question. That actually is really important. Like, I'm not going to be here to tell you, don't forget, this is how you have to start it. You have to come up with the idea that, okay, it's asking for a slope of a tangent. That means derivative. You have to get that. Okay, slope of a tangent means derivative. That's this whole question. Okay, so we're finding our f of x plus h minus f of x all over h with the limit as h goes to 0. This is essential. That is essential. You need that every single step until you evaluate the limit. Some of you did not have that. Make sure you include it on a quiz or a test. If you don't have that, it's wrong. Because without it, you're just finding a slope of a secant line. You need it for the derivative. Even if you plug it in at the end, you have to have it along the whole way. Okay, so let's evaluate this. X plus h squared plus 2xh plus h squared. You will get that quickly if you don't know it now. Will, I promise. Here, I get minus 5x minus 5h. Don't forget to distribute the negatives. That's a common mistake from students. Makes it hard to cancel out, gives you kind of a weird answer later. Okay, and then still plus 8. That portion, we are not done. I need to distribute the 3. Don't forget to distribute the 3 to everything. So that gives me 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 8. Notice I have labeled this. What I am finding is f of x plus h. That is labeled correctly. I don't need a limit here because that's what I'm finding. Over here, I am finding f prime of x. Right? So now I'm going to set up limit as h goes to 0. I'm going to write that whole thing. Yes, that's annoying. You still have to do it. H squared minus 5x minus 5h plus 8. That is this portion, f of x plus h. I also need to write my minus f of x, which is whatever this is, but with all the signs reversed. So minus, pick blue maybe, minus 3x squared plus 5x minus 8 all over h. Okay? That's the setup. We haven't actually done anything. We've done a little bit, not much. Okay, we're going to simplify. We're going to cancel out our f of x with our minus f of x. Or I'm sorry, we're going to cancel out our minus f of x with the things that we can in our f of x plus h. What I have at this point is still a limit as h approaches 0. I have 6xh plus 3h squared minus 5h over h. I can also take an h out of every term. And now I have the limit as h approaches 0 of 6x plus 3h minus 5. Some of you got here and stopped. We're taking the limit as h approaches 0. Now that I've canceled out an h over h, that was the whole at 0. Now I can evaluate by plugging in 0 for h. So now is when I don't need to write limit because I'm actually evaluating that limit, and I get 6x minus 5. So what we found was that f prime of x equals 6x minus 5. The question asks us to find an equation for the slope of the tangent line at any point on that graph. That's what this is. Okay? This is an equation for any point on this cubic graph for the slope. If I wanted to know what is the slope at 0, I would plug in 0 into this equation for slope. Okay? Common mistake, I'm going to call you out, Peterson, because a lot of people do it. Common mistake is to think that the answer is 6. Because if this were its own line, the slope of this line would be 6. The issue with that is that 6 is not the slope at any point on this. Oh, sorry, it's a quadratic, not a cubic. Right? I have some quadratic. 6 is not the slope everywhere. Right? There might be a point where the slope is 6, but it's not everywhere. At any point that I wanted to find on that quadratic, I would use this equation to find the slope. Okay? Some of you then tried to take this and plug it into a y minus y1 equation. But we don't have a specific point. If they then said, and then create an equation for the tangent line, right? If they said create an equation of a tangent line at x equals 2, then you would plug that in. And we would do what we did yesterday, y minus y1 equals m times x minus x1. It didn't want an equation of the tangent line. Reading is really hard, and it's important. Because it seems like it says equation of tangent line, right? You have to read carefully. Equation for the slope of the tangent line. That's that equation. Make sense? Fantastic. Okay, go ahead and draw these really quick. A through D. We're going to talk about some graphical interpretations of a derivative. Oh, no. Yeah, we'll see. Yeah. I'm not like on a call trying to record. I guess I should have said that. That's kind of weird. No, you're not. No, just me. I'm recording it for potentially posting for later. Yeah. So my audio is synced. Like I said, we'll see. Might be crap. TBD. Okay, right underneath each one and do it under. Don't do it to the side. Underneath each one, just like I've shown, draw another like quick XY axis. It is important it's underneath because there's going to be some stuff that line up. That's why I have it drawn this way. Sorry, I should have said that first. Okay, so I have some quadratic like this. I haven't labeled anything. I don't have any like numbers on here. Underneath that, it doesn't have to be huge, but just underneath that, give a little space. We're going to try to draw a possible graph of the derivative. We're going to consider some important things we talked about yesterday. Okay. We have these drawn-ish. We're close. Okay, yesterday we talked about things like if a function, if my graph, f of x, is increasing. If my function is increasing, what would be true about my derivative where my function is increasing? My derivative would be positive, right? We looked at some values yesterday for my quadratic. We were on a part of the quadratic that was increasing, and I got a positive answer for my derivative. My slope was positive because my function was increasing. Okay? The reverse is also true. If my function is decreasing, and we always walk left to right, so some guys say this is going up on both sides. You are walking from left to right, so you would be walking down, that means decreasing, and then up, that means increasing, always moving from left to right. Okay? So anywhere over here, my derivative, if I had a tangent line, would be a negative slope. Anywhere over here, my derivative would be positive because my function is increasing. Does that make sense? How about right here at the minimum? What do you think the derivative or the tangent slope would be at that point? Yes. 0. It would be 0 because the slope would be 0. Okay? So that's where I'm going to start. I'm going to start right here. Whatever x value this is, that slope is going to be 0. What's that going to look like on my derivative graph? So this is a graph of all the slopes. What would that be? Not a horizontal line, a 0 value. A value of 0. Because f prime of x is a graph of all the slopes. So I know right here, this slope equals 0. On this graph, at whatever that point is, like if this is 2, f prime of 2 equals 0, meaning it shows up at 0 here. Okay? To the right of that point, we said since this graph is increasing, my derivative will be what? Positive, meaning it will exist up here. Positive. Okay? On this side, my function is decreasing. My derivative will be negative. Okay. Just to the right of 2, it's a little bit positive. Do you see that it becomes steeper as we move farther out? What do you think that would mean as I move farther out on my f prime graph? If my function is steeper, my slope will be what? Higher and higher and higher. So it's going to be like this value and this value and this value and get bigger and bigger and continue to get bigger because it's going to continue to get steeper. Okay, on this side of the graph, it starts out at 0 right here at like 2 or whatever we're going to call this. And it is negative, but only slightly. And then it gets steeper and steeper and steeper and steeper and more and more and more negative, right? The graph is actually getting more positive, but the slope is getting more and more negative. Does that make sense to everybody? Okay, so as I go this way, I'm going to get more and more and more and more negative. This derivative ends up being a line that looks like this. We'll talk about how you can identify what the actual shape is in the future, but for now what matters, positive, 0, and negative, based on increasing, minimum, decreasing. That makes sense to everybody. Okay, we're going to use that same logic here. Do I have a 0 slope anywhere on this graph? No. Okay, so that's how we started the last one. We found our 0 slope. We started there. What is true about the slope anywhere on this one? It's constant. It's the same slope. No matter where I am, it's the same slope. What is this function doing as I walk left to right? What's it doing? Decreasing. What will be true about the derivative? It will be negative. What do you think our derivative would look like? Anyone have a guess? What would our derivative look like? Yes, sir. A horizontal line where? In quadrant 3 and 4. I agree with you. Like this, horizontal line, because it's whatever that negative slope is. Maybe it's a slope of -2. That means we're going to have a horizontal line at -2. Okay, because that slope is always the same. If I'm here, it's -2. If I'm here, it's -2 anywhere. Okay? Questions on that so far? All right, next one. I have this sort of cubic graph. I want you and your partner to identify where are there 0 slopes, like a slope that is equal to 0. Where is the slope positive? Where is the slope negative? With your partner, go. Again, you don't have to draw the picture yet. I want you to figure out where are there 0 slopes. Where would your derivative be positive? Where would your derivative be negative? For stuff that's negative, I would show it underneath the x-axis because it'll make it easier to draw the picture later. Okay, I've got some really good pictures for you guys so far. Okay, so you should have identified that there are 0 slopes at the min and max. Okay, we have a 0 slope at that min and that max, so that corresponds on here to a 0 value or an x-intercept. Okay, wherever the slope is 0 on this graph, the value is 0 on our derivative graph. It's a graph of all of the slopes. Okay, several of you identified that this graph, since I'm always walking left to right, is decreasing before that minimum, meaning it will show up as what kind of a value on this graph? Negative. I would put that negative in the negative space so that you know you have to draw a graph down here. Okay, some of you just drew negative and then other stuff up there. I would put negatives down here, positives up here. Just makes it easier to graph it later. Okay, then after that minimum, I'm walking this way, I'm increasing, meaning a positive value. So again, I would show that here in the positive space above the x-axis. And then after that, we're decreasing again, so we got negative. As I walked around, several of you had this. So great job. That's a lot of the hard work so far. Okay, there's some questions on quest that are going to be match the derivative with the f prime or whatever, the f with the f prime. That's a lot of the work if you can think through this process. Okay, I'm going to ask you a different question. When is the derivative greatest? As in, when is the derivative most positive? You can answer conceptually. Yes.
The middle of the two.
In the middle of the two zeros. I agree. Why?
Because
That's the steepest part. So look here. I have a flat slope, 0, and then I'm increasing, and then I go back to a slope of 0. Right? So somewhere in there was the steepest part, was the hardest part of that hike. Right? The steepest part, which means it's going to be the highest, most positive value. Somewhere in between those two. I don't know exactly where. Somewhere in between those two. Okay? What happens as I go further to the left? More and more negative, right? Gets steeper and steeper and steeper and more negative. What happens as I go further to the right? More negative. As farther I go, the steeper it gets. Meaning, I'm going to have something that looks like this. Okay? Some of you knew that. Doesn't matter if you knew it. Great. If you did, don't worry if you didn't. Okay? It needs to get more and more negative because the slope gets more and more negative. Okay? All right, this next one is very hard. Looks easy. Looks like maybe it's going to be super easy. It's not. This one is more challenging. Parts of it are easy. Okay? Want you and your partner to identify maybe positive, negatives, or zeros on this one. See what you can determine about this. Go.
oh, wait a minute.
Okay. I didn't give you too much time because I want to make sure we can get through this. There's a piece of information you don't know yet, so I want to talk through this. Y'all are so excited, and you're doing very well. Some of you are doing very well. On this side, if it was a line, we had a line over here. Right? If we had a line, that showed up because it has the same slope this whole time as a horizontal line. This horizontal line was negative because why? Why was this horizontal line negative? Because the slope is negative. The function was doing what? The function was decreasing. Right? My function is decreasing. That means my derivative is negative. So a portion of this is decreasing. That means I'm going to have a negative derivative. Right? It's going to exist in the negative area. This part is increasing. So right after wherever this is, I'm going to have positive. My function is increasing. Okay? Also, yes, I'm going to have a horizontal line. Just trying to figure out where this point is. Let's say here. I'm going to have a horizontal line here, and then I'm going to have a horizontal line here. Okay? Most of you had, or some of you had this, which is great. Okay? Now, what is the slope right there? No. The slope right here is 0, right? It's a perfectly flat slope. Okay? Yes. It is undefined. There is no derivative at this point. There is no derivative at this point. There is no slope at this point. I'm going to give you an explanation in a second. If there is no derivative at this point, what would that show up on as our derivative graph? Open circles. You're exactly right. Open circles. There is no derivative on this graph, or there is no derivative on this graph. So at that point, there is no value for that. Okay. Here's what is required for a derivative. We're going to go back to our definition of continuity to get there. So what was our definition of continuity? If something is continuous at C, 3 requirements, what were they? Somebody give me them. Yes. They are equal. The limit from the left is equal to the limit from the right, which is also equal to what? Yeah, perfect. And I'm just calling that value C, right? So if a function is continuous, the limit from the left equals the limit from the right. You're right that they approach the same value, but we're saying if that's true, that the limit is equal, right, from the left and the right, and then that's equal to the value at the point. That's our definition of continuity. We have a similar sort of definition for a derivative. Anyone generally describe what they think it might be in general? So for a value to exist, for a function to be continuous, the limit of f of x, so whatever that y value is from the left, has to be the same as the y value from the right, has to be the same as the y value at that point. There's only two requirements for a derivative to exist. Yes. Correct, exactly that. You have to approach the same derivative from the left and the right. Okay, so I'm going to write that here. The limit of f prime of x as x approaches c from the left has to equal the limit of f prime of x as x approaches c from the right. And there is one other requirement. F of x must be continuous at c. Okay? So if it's not continuous, it doesn't have a derivative. So if your original function has a jump, even if the slope from the left and the right are the same, there is no derivative at that point. Okay? So it has to be continuous, and the derivative from the left and the right have to be the same. Here's what that means graphically. Smooth transitions only. If I have anything pointy, that is going to be a different slope from the left and the right. Anything pointy. In calculus, anything pointy we call a cusp. Sometimes you'll see it look like this, pointy, right? Or sometimes just like absolute value. That's also a cusp. Okay? But on this side, as we approach, we have some slope that's like -2. On this side, maybe it's +2. Those are not the same slope from both sides. Again, we're looking for smooth transitions. Anywhere there's a smooth transition, there will be the same derivative from left and the right. Okay? Does that make sense? Questions? All right, let's do another example of fun stuff with definition of the derivative. Write down f of x equals square root of 2x minus 3. F of x equals square root of 2x minus 3. I'd like you to evaluate f prime of x using the definition of the derivative. What does that mean? What do I want you to do? Find the derivative. What's that mean? What are you going to do? Yes, correct. So what are you actually going to do? Like, tell me some of your steps. What are you pointing at? You're right. This whole thing, f of x plus h stuff. That's what I'm going to ask you to do. That's what that question means. So find f of x plus h. Okay? Simplify the equation as much as possible. With your partner, go. Yes, if it's not asked specifically like find f prime of 2, f prime of x means at any point. The f of x plus h is easier to find on this one. The simplification is harder. Ooh, that's correct. Someone knows the right vocab. Someone knows what to do. We did some of this practice with regular limits. guys are too smart. I've realized. I'll give you harder problems. Okay, it's allowed to be in the bottom. It's allowed to be in the bottom. Those of you who are in the know, what do you need to do to simplify this? Multiply by the conjugate. It's the only way we can deal with these square roots. We got to multiply by the conjugate. Yes, that looks very scary. I promise it simplifies quite a bit. It does look scary, I know. Eventually, you are going to try to cancel out an h over h. So you don't need to distribute that h in the denominator. Oh my God. Tasha not getting credit. She's forgetting her limit. Worst calculus teacher ever. Y'all are funny. It's a special case. I should all adjust this for the next class so that it doesn't look like that. Has to do with this coefficient. That's why. But that's random. So, multiplying by the conjugate, right? Oh. This times this equals this minus this times this. So, square root of 2x minus 3 times square root of 2x minus 3 is 2x minus 3, but you're subtracting that. So, it's minus 2x plus 3. And remember, you should always be able to cancel out. Okay? Where did what come from, Elijah? Because we're taking the limit as h goes to 0. Okay, guys, get going on your homework. Seriously, you can do a bunch of your quests. You can do a bunch of your Khan Academy. Get going. Yeah. Cool.
Yeah, it's in a while, kind of.
Cool. You'll get the notes from a friend. Have a great day, guys. Excellent work. Yes, sir. Okay. You need to adjust it and leave a note on Classroom for me that we had this conversation. So just remind me we talked. Bye. Thank you, too. But yeah, just go ahead and resubmit it. Thank you. Thank you.
Thank you.
Wow, that's good. That's impressive. Yeah, go for it. Yeah. Let's hear it.
Lily's such a
doesn't really work on that. But yeah, that is the right logic. Yes.
I had a question. So how do you find the slope on the point using a graph?
You just look nearby, right? So you're just trying to estimate what is the slope right here.
So would I just use that point in that?
I would use points that are nearby, which I have a
Deliberative, that's the word.
But like, see how the slope is going like this?
Uh-huh.
So try to like imagine this as a line that's extended, and take 2 points and then come up with the slope. It's definitely not 0. Fair?
Yeah. Yeah.
It's definitely negative.
Mm-hmm.
Right? So I would compare some of these values. You don't have to know for sure what it is, but it's like 3 and 1/3 are pretty different.
Right.
So compare what the values are near them.
So for this one, since it's not steep, it would be 1/3. That's a shallow.
But careful because it's negative, right?
Oh, it's negative, right?
Yes!
Why do we have a Google Meet?
We don't. We did in the last class. And it's over. And we'll see how it went.